All right, so beginning Unit 3, Unit 3 focuses on lines and angles, more specifically parallel lines and perpendicular lines. So we're going to begin today's lesson with a couple 3D figures, three-dimensional figures, where we're naming parallel lines, perpendicular lines, skew lines, and then even parallel planes. Okay, so our formal definition of parallel lines are lines that are coplanar and do not intersect. So hopefully you can see a couple of examples of parallel lines on this. We can call this a cube. Assume every single side has the same length. So remember, the parallel lines, they need to be on the same plane. So we could name AE being parallel to BF. Why don't you take a second to go name another pair of parallel lines on this figure. There were plenty of options. Maybe you wanted to name some on the side of this cube. So you could have said FH and BD. We just need to make sure that these lines are coplanar. They lie on the same plane. Okay, but plenty of examples here for parallel lines. Let's continue with perpendicular lines. Perpendicular lines are lines that intersect at '90-degree angles. Okay, and because this is a cube, there's going to be a couple different lines that intersect at 90-degree angles, specifically in each corner. So if we're looking at the front face of this cube, we could name EG being perpendicular. Our perpendicular sign is just this upside down capital T, forming a 90-degree angle. EG is perpendicular to GH or HG. Great. Why don't you take a second to go name another pair of perpendicular lines. Maybe on the top of this cube you wanted to name AE being perpendicular to BA. AE, BA, perpendicular. But hopefully you notice, because they're intersecting, they're going to be sharing. There's going to be the same point in both of these because these lines are intersecting at that point, forming 90-degree angles. Okay, skew lines. Skew lines might be new to some of us. Skew lines are lines that are not coplanar, not parallel, and therefore they do not intersect. Okay, so I'll give you an example of skew lines, and then we'll go have you find some on your own. But AE is on the top part of this cube. If we wanted to name a line that was skew with AE, we could pick a line that is not on that plane and not going to intersect, so we could say BD. AE and BD. We could not say AE and EG because those lines would be intersecting. We could not say BF because those would be parallel, so they need to be not coplanar, not parallel, and they're not going to intersect. So why don't you guys take a second to go find another pair of skew lines. We don't have a symbol, just name those two lines after you find them. Great, plenty of examples here. Maybe you found CD and EG or GE. Plenty of examples of skew lines on this figure. And then last but not least, parallel planes, just like parallel lines, but planes that do not intersect. Okay, so that would be the front A couple of examples, you could say the front and the back of this cube. We could say top and bottom of this cube. And when we're naming parallel planes, remember any 3 points that are not collinear. So plane A, E, F would be the top part of this cube is parallel to plane G, C, H. Any 3 points, and there's only 4 that lie on these planes, so pick 3 of those 4. Great. There's more examples we could have done there, but let's practice some on this figure, okay? Practice naming, and now these are segments, right? We don't have these lines extending, so we're going to name a pair of parallel segments, skew segments, perpendicular, and parallel planes. Now it looks like using this rectangular prism, okay? So start on A, parallel segments. Go ahead. We're all going to have different answers here, but maybe you had BF is parallel to CG, BF and CG. You could have also done BF and DH. Those are on a diagonal plane across from each other, okay? But just parallel lines, lines that are not going to intersect. How about for skew? Skew, go ahead and name a pair of skew segments. Maybe you said GH and EJ. GH, EJ. I know it looks like those are intersecting, but really they're not. It's a 3-dimensional figure. They're not coplanar. They're not intersecting. Skew segments. How about perpendicular? Maybe you had CD is perpendicular to DH. CD, DH. We know that every single side, because it's a rectangular prism, they're going to meet at 90-degree angles. So you could have picked any face and have 2 of those sides intersecting. And then finally, pair of parallel planes. Maybe you wanted to do plane DEH is parallel to plane CBF. DEH would have been the right side, CBF would have been the left side of this rectangular prism. But more than one answer you could have there, so if you didn't have something that I had, just make sure when I highlighted those segments or planes on the figure that it looks similar to what you had. Okay, let's talk about angle pairs. We have angles that are not always right angles from perpendicular lines, but we have angle pairs that are formed from a transversal. And a transversal is this line right here. It's line T. So a transversal is a line, and let's name this one on here, line T, that intersects 2 coplanar lines at 2 different points. And because we have this line, one line intersecting 2 different lines, it's going to form 8 angles, okay? And each of these angles, they have a special relationship to each other, okay? So a couple words to help describe these angles. Corresponding angles are angles that lie on the same side of the transversal and same sides of the lines being intersected. So if we pick one side of the transversal, we would be looking at these 4 angles, or you could pick the left side. And then we want to pick 2 angles that are on the same sides of the lines being intersected. So corresponding angles, we're looking at 2, 3, 6, and 7. Say they were both above those 2 lines being intersected. Angle 2 and angle 6 would be an example of corresponding angles. On the other side, we could say 4 and 8. They're both on the left side of the transversal, and they're both below those 2 lines being intersected. Okay, corresponding. Think corresponding position, same position. Alternate interior angles are angles that are non-adjacent and they lie on opposite sides of the transversal between, I'm just going to abbreviate BTW, between the intersected lines. Righty. So if we're looking at all the angles that are in between the intersected lines, that would be 4, 3, 5, and 6, and they need to lie on opposite sides of the transversal. So yes, we could say 5 and 6, they're on opposite sides of the transversal, but they need to be non-adjacent. Non-adjacent. So we could not say 5 and 6, we would instead say 5 and 3, or angle 4 and angle 6. Just two pairs. There's always just going to be two pairs of alternate interior angles. Just like there will always be two pairs of alternate exterior angles. They lie on the opposite side. And outside the lines being intersected. Okay, so that would mean 1 and 2, or 8 and 7. I know 7 and 8 are on opposite sides, but again, these need to be non-adjacent. So then we would say angles 8 and 2 are alternate exterior. And then we could also say 1 and 7. Angle 1 and angle 7. Or angle 2 and angle 8. Outside the lines being intersected, opposite sides of the transversal. Okay, and then our last pair of angles formed by a transversal would be same side interior. Sometimes you might see the word consecutive used to describe same side interior angles. But these are angles that, well, you could take a guess. They now lie on the same side of the transversal. And between the intersected lines. Okay, these are also non-adjacent. Remember, all the adjacent angles in this figure, those would be a linear pair, right? 8 and 7, they're adjacent, form a linear pair, form a straight line. So, consecutive angles, or same side interior, just looking at the interior angles, they now need to lie on the same side. So, we would say 3 and 6, or 4 and 5, both pairs of same side interior angles. 3 and 6, 4 and 5. Okay, let's take a figure that has two lines being intersected by 1. So this blue line is going to be our transversal. And go ahead and give an example of each. Corresponding, alternate interior, alternate exterior, and same side or consecutive. Just one of each. Okay, I might not name yours on here, but that's okay. Corresponding. 1 and 3 is an example of corresponding. Alternate interior. 2 and 7. Alternate exterior. You could have done 4 and 5, or 1 and 8. Same side interior, you could have done 2 and 3, or 6 and 7. Okay. And then what I want to finish up with would be you identifying transversals from a given angle pair. So what we want to do is we want to locate the line that's intersecting at the vertices for those angles. So if we want to identify that there's clearly 3 lines here, all 3 of these lines could be they are transversals, but we want to know the transversal that's forming an angle pair with 4 and 6. Okay, and it would be the line that contains those 2 points. So if you notice this line, line M, contains those 2 points, and then we could identify 4 and 6 as alternate exterior angles. They both lie outside, they're on opposite sides of the transversal. Let's try one more together. 2 and 6, angle 2, there's your vertex, angle 6, there's your vertex. So now this purple line would be our transversal, which is line N. And 2 and 6, okay, those are both located inside our 2 lines, and they're on opposite sides of the transversal, so alternate interior angles. All right, why don't you try 2 and 5? 2 and 5 had the same vertex as 2 and 6, okay? So line N is still your transversal, but these are not on alternate sides. 2 and 5 are on the same side, and they're located on the interior. So same side, interior angles. Okay, last one, angle 1 and angle 3. Here's the vertex for angle 1. Here's the vertex for angle 3. That means our transversal is line L. And those would be same side of the transversal, same position, but one is in the interior, one is in the exterior, so these would be corresponding angles. Same position on the lines being intersected, and same side of the transversal. Okay, a lot of vocabulary for this first section, a lot of identifying angle pairs and transversals. Get started on your homework, and we'll answer any questions you have in class.